Hi dear children, welcome to the chemistry class. In the first part of this chapter, we just came to know about the history of periodic table and also we discussed about the Mendeleev's periodic law, right? So before starting the class, let's recall about the history once again. So we know that Anton Lavoisier, he classified the elements into metals and non-metal, but he was not able to classify the metalloids. After Lavoisier, Dauberner came. He put forward the law of triads, but all elements could not be classified into triads. That was the limitation. Newlands, he proposed the law of octaves, but limitation was the elements with higher atomic mass didn't obey this rule. Later, the Russian scientist Dmitry Ivanovich Mendeleev, who proposed the periodic table for the first time, and he proposed Mendeleev's periodic law. So, up to this much we have covered in the previous video. So, today we are going to discuss about the advantages and limitations of Mendeleev's periodic table. Moreover, we will learn about modern periodic law. So, let's start the class. Okay, let's discuss about the advantages of Mendeleev's periodic table. First point, elements were classified in such a way that elements of similar properties were placed in the same group. That is, the elements showing similar properties were arranged in the same group. It made chemistry easier to study about those elements. Second point, some elements didn't follow the correct ascending order of atomic masses. He pointed out that this could be due to wrong determination atomic mass. Later, this led to the correction of wrongly determined atomic mass. As I told you, the Mendeleev's periodic law suggests that the elements are arranged in the increasing order of atomic mass, right? So while arranging the atomic masses, he came to know some elements are not following the correct order. So he corrected the wrong ones. For example, initially the atomic mass of beryllium was determined as 14, but later Mendeleev changed it to 9. Third point, columns were left vacant for elements which were not known at that time and their properties were also predicted. You know that only few elements was discovered at that time. So he left some column for the elements that were not discovered and he predicted the properties of elements also. Alright, did you understand the advantages of Mendeleev's periodic table? So shall we discuss about the limitations? Okay, first point, elements with large difference in properties were included in the same group. For example, hard metals and soft metals are included in the same group. So, it was difficult to study about the properties of these metals as they were included in the same group. Second point, no proper position could be given to the element hydrogen. As you know, hydrogen is a nonmetal and it exists in gaseous state, where the elements that placed along with the hydrogen are existing in the solid state. So it was one of the limitation. Third one, the increasing order of atomic mass was not strictly followed throughout. As we discussed earlier, Mendeleev's periodic law was about atomic mass. Elements like cobalt, nickel, tellurium, iodine with a higher atomic mass couldn't placed in the proper position. Okay children, so following are the limitations of Mendeleev's periodic table. Elements with large difference in properties were placed in the same group. No proper position was given for the element hydrogen and the increasing order of atomic mass was not strictly followed throughout. When Mendeleev framed the periodic table in 1869, there was no clear idea about the fundamental particles or structure of atom. It was mostly through his X-ray diffraction experiments he gave some serial number to the elements, and these numbers were now known as atomic number. Based on this, the periodic law was modified. So let's see the modern periodic law. Modern periodic law states that the chemical and physical properties of elements are periodic functions of their atomic numbers. In Mendeleev's periodic law, we learned the chemical and physical properties of elements are periodic functions of their atomic masses, right? So, in modern periodic law, atomic number is basis for all the elements. On the basis of modern periodic law, the periodic table was revised. Let's analyze the features of modern periodic table. There were vertical columns in the periodic table, and these columns are called groups. The elements of the groups exhibit similarity in chemical and physical properties, and the horizontal rows are known as periods. So now can you tell me how many periods and groups are there? As I told you, the vertical columns in the periodic table are called groups and horizontal rows are called periods. So in the modern periodic table, there are 18 groups and 7 periods. Among this, the shortest period is the first period. It consists of only 2 elements, hydrogen and helium. Okay children, let's conclude today's class. See you in the next class with another new topic. Learn well. Thank you for watching this video.